Hello, my name is Braylon Morgan. I am a college senior studying computer science at the University of Houston downtown. And in this video, we're going to be discussing Wireshark. Now, for those who are not familiar with Wireshark is or what does it even do? Well, we are on the Wireshark main page, and as you can see, it is displayed as the world's most popular network protocol analyzer. Now, what exactly does this mean? It means that it has the capability of capturing packets from network connections in order to determine how the network flows between the computer and the network itself. Now, Wireshark has three main capabilities: packet capturing, filtering, and visualization. For packet capturing, as mentioned earlier, it listens to the network connection in real time and then grabs entire streams of traffic. For filtering, you can obtain just the information you need to see from all the random live data captured. And from visualization, Wireshark allows you to dive right into the very middle of a network packet, while it also allows you to visualize the entire conversations and network streams. The goal of this video is to explain how to set up Wireshark onto your Windows computer and explain how Wireshark is used in network analysis. Alright, with that being said, let's go ahead and get started with downloading Wireshark. Now, to get to Wireshark, you're going to go to this link here, www.wireshark.org, which will take you to this homepage. And you can either click on the download Wireshark now, or you can click on the blue Get Started button. And both will basically take you down here to the download Wireshark section. And you can choose between either doing the stable release 4.0.7 or the old stable release. We're going to go ahead and do the Windows Intel installer. And as you can see, I've already have Wireshark downloaded. So basically, you can just follow through the steps. We'll follow through the steps again, just so we can show you exactly where to go. You'll click Next. Make sure that all these are checked under the Choose Components. Make sure that the association trace files extensions are checked. You can do whichever you want for the shortcuts. You're going to do Next. Now, this right here is the most important feature in terms of using the Wi-Fi interface, the NP-CAP 1.76. I definitely recommend having this installed if you do not have the NP-CAP installed. All right, and then you'll just continue following on with the steps until Wireshark is downloaded. And once that is done, we'll get to the interface. Okay, once you have downloaded Wireshark, you will see this is the main page. As you can see here, it basically has Welcome to Wireshark and the capture interface. And the capture interface will basically show the main network interfaces to which Wireshark can use in order to attempt to capture packages. As you can tell from right here, is already able to read the network communication from both the Wi-Fi and the adapter for loopback traffic capture. And so before we go into the packet compactor, we're going to go ahead and first go over the filter bar. With the filter bar, this is how you're able to, once you start capturing the packets, you can use the filter bar to be able to, let's say, separate packets that are HTTP based or IP, search for IP addresses or other different types of protocols. And in each packet, you can also view packet details as well as the list of packets that each protocol runs. So for now, let's go ahead and get started on capturing packets. Now, in order to capture a packet, you have to first select the interface. And so since we're focusing on Wi-Fi, we'll first select Wi-Fi interface. And now if you go to the top left here, you'll see the symbol, the blue shark symbol here to start the capturing packets. But before we do that, let's go here to the screw symbol and do capture options. And let me just quickly bring these out. And as you can see here, it shows the interface as well as the network traffic that's currently being read, the type of link connection, promiscuous mode, the snap min, the buffer, and the monitor mode. Now, when using Wireshark on Windows, what some network adapters do not run monitor mode. It's actually preferred to use a Linux computer in order to use monitor mode on Wireshark. However, we do have a mode that's called promiscuous mode, which is basically where the network adapter captures all packets of the network, not just those intended for the specific device. Now, just in case you wanted to know what exactly is your network adapter, you will right click to start, go here to device manager, and you would basically just come all just continue to come here to where you see network adapter and left click, and it's going to be right under the Bluetooth device. So as you can see, mine here is the Intel Wi-Fi 6. That right here is my network adapter, just in case you were curious. All right, so we're going to choose Wi-Fi, and we're going to click Start. As you can see, Wireshark is at the moment capturing all the network communications that is happening between the computer and my home network. And you can choose to continuously have this run as long as you want, but we're gonna stop it right around 200. Boom. So right now we have 202 packets. Well, actually, we got to packet number 202. But if you want to know the number of packets you actually have, you'll just simply come down here and it will tell you how many packets, it will tell you how many packets you have and how many they are being displayed. And as you can see, there are different types. It basically shows you the number of packets, how long it took to get the said packets. It shows you the source IP address, the destiny IP address, the protocol of the packet length in bytes, and the info. All right, and the next thing we're going to talk about is the importance of the All right, now we're going to quickly discuss the display filters. Now, the concept of the display filters is to help narrow down the capture packets for a specific, for either a specific IP address or a specific protocol, or even to determine what info is being presented. Now, as you can see, we have 206 packets. So this is just a small number compared to a pack compared to a network that can send over 500 packets in a minute. So we're gonna, as you can kind of see, Wireshark, when it comes to the protocol, it separates the protocols by color. So you can see the ARP protocol is like a tan color. The SSDP is a sort of light blue color. And we can continue to scroll. The TLS is in a different color as well. So now let me show you the display filter. Now let's say I want to take a look at a specific IP address. So we can quickly go here. We'll say IP, and you already have your list of addresses or the list of filters to which you could put in. And so we'll type in ip.addr and equal, and then we'll put down the IP address that we want to look at. So we'll say 169.254.189.161. You just hit enter, or you can click on this checkbox. Now, if you notice that you typed it in incorrectly, you'll notice that it's not displaying anything. As you can see here, display is 0. So if you mistyped it, that's okay. You'll just retype the source code again, and now you can see that it has all of the IP addresses from the requested source address, and it shows you out of the 206 packets, it shows you 43 packets total is now being currently displayed. And you can see the trend out of this IP address is sending info to the same destination address as well as using the same protocol type. So this is how you can use display filters to kind of help determine what individual IP addresses are doing and what type of protocols are being used to help send messages. All right, so now we're going to discuss the protocols as well as what each individual protocol may work. Now, there are a lot of different protocols in in the network, but the most common ones that which you may see are like the SSDP. You can come here and you can see that it's called the Simple Service Discovery Protocol. Then you have what is called the TLS protocol, which is known as the Transport Layer Security, which is basically encrypted hypertext. Then you see the regular TCP protocol, which stands for the Transmission Control Protocol. And you may even see a few, if you scroll down, you may even see a few rare ones like this one, which is the Multicast Domain System, or the ICMP, which stands for the Internet Control Message Protocol. And then, of course, there's the typical HTTP, the HTTPS, and what is called the UDP protocol. There are many different protocols. Not every network may use may use the protocol, but those are basically the common protocols that may be used. Now, you may be wondering, why exactly are protocols important? Well, the reason why they're important is because they can help assist with efficient troubleshooting. They can also help with detecting anomalies within the network, and they can also help with optimizing performance. Now, let's say you're not really comfortable with this capture packets, and you want to have a new one. It's real easy to do. All you'll do is go to File, you'll go to Close, do not go to Quit, you'll go to Close, and then it'll give you the option if you want to save, but the capture package will be lost. You can do Continue without saving if you don't want to catch these particular packets. So you do Continue without saving, and just like before, you'll take you back to the home page. We'll click Wi-Fi, and you can either double click it or you can even come here to the blue shark button. And let's say this time you now actually have the package to which you want to save. You'll come here to the stop, which is right next to the red square next to the blue shark fin. And now let's say you want to take these packets and save it onto your file. As you can see, this is a completely different set of packets. Instead of the 202 packets we had earlier, we now have 289. And so if you want to save the package, all you'll do is click on File, Save As, or you can use the Windows shortcut Control S. And then under Data Files, you can save it. You mainly want to save it as Wireshark, but you can also drop down box here to see the different types of files in which you can save it under. But for now, we'll just save it under the Wireshark, and we'll just say Wi-Fi test. You'll hit save, and now you can close out the Wireshark. And as you can see here, now under the open, if you need to quickly go back into the file, the capture package that which you just did, that you've just done, you'll just double click it and then boom, it'll take you right back to your original set. And that is a general observation of Wireshark, just how you can use it to go under the Wi-Fi and read the communication to see how the network is communicating between it itself and the computer. I will leave Wireshark website description in the description below. Anyway, thank you for your time. Enjoy your day. Goodbye.